All right, so today we're in section 1.2, adding integers. We talked the other day about an integer. What is an integer? Anybody remember? What's an integer, Gabe?
A negative number?
It can be a negative whole number, negative number that does not have a decimal. So give me an example of a negative integer. Just anybody. Negative 4. Negative 3. Negative 10. Negative 2. All right, what about a positive integer? 10. Just 5. Okay, so we have a good idea of integers, okay, whether they're positive or negative. Is an integer the same thing as a whole number? No, because whole numbers are only positive, okay? All right, so when it comes to adding integers, all right, what does that look like? How do we understand kind of some of the background, reasoning why our answer ends up being a certain sign? Well, there's rules that we can follow, and we can also look at a number line. So really your book focuses at the beginning on showing you on a number line why your answer ends up being a certain value. All right, so everybody has their notes labeled, correct? Okay, so I'm going to switch screens real quick. So go ahead and just take just a minute to write down this number line. All right, and then we have an expression at the top. This is a very basic, simple expression for adding integers. Negative 3 plus 4, but we're going to show that on a number line. Okay, that kind of helps us understand the why behind our answer. Okay, so here's how we show this expression on a number line. Okay, so 0 is always our starting point. And now from 0, would I go left 3 or right 3? I go left 3 because it's negative. So we know that negative numbers trend to the left on a number line because I'm taking away. So I go left negative 3, and I just label that. Okay, I go left negative 3. And now where do I go? Do I go right 4 or do I go left 4 more?
Right.
I go right 4 now. Why? Because 4 is positive. So now I go right 4 units and I land on 1. So that is my answer. Okay? All right, so how many of you guys are kind of visual learners? Visual? Okay, so I'm kind of more auditory, right? So like the books that you can listen to, I'm all about that. How many of you guys like zone out on audiobooks? Do you like audiobooks? Not, maybe? Okay, so we all learn different ways. Our visual learners really like number lines because you can kind of see the why. You can see the why behind it visually. All right, but do you want to draw a number line every single time you solve one of these? No. Okay, so it shows us the why behind it, but we like shortcuts. We like doing things fast, okay? And that's where our terms and our rules come into play. So we have 3 terms that are really important, especially our third ones, okay? So we're going to take just a minute to write down these notes. It's all important. That's why I'm highlighting all of it, okay? It's all important. The additive inverse is the opposite of any number. All right, and then, like I said, give you a minute to copy it down, then we're going to talk about each one of these. Okay, so the additive inverse. Guys, this is a fancy word for opposite, okay? The opposite value of a number. So I'm going to give you a number, an integer, negative 4. So if I were to ask you on a quiz, homework, test, what is the additive inverse of negative 4? You would say the opposite, which is 4. All right. So what is the additive inverse of 7? Negative 7. All right. So you're kind of catching on with that. It's just the opposite. So here's what the additive inverse property says. Take a number and its additive inverse, opposite, and the answer is 0, always, all right? And we know that, right? Any number in its opposite will be 0. Negative 4 plus 4 is 0. All right? You just didn't probably realize that there was a name for that. It's called the additive inverse property. All right? We'll explore more of that, I think, in example 3. Okay, so rules for adding integers. We've got a catchy little saying, okay? It is a song. We're going to kind of go with the rhythm. I'm not much of a singer, okay? But here's the saying. Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. All right, you ready? Try to say it with me. Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. Okay? What does that mean? We're talking absolute values. If the numbers, if the integers have the same sign, we add their absolute values and keep the common sign. Same sign, add and keep. Different signs, subtract their absolute values. Take the sign of the larger number, then you'll be exact. All right? And that's where we're going with our examples today. Adding integers with the same sign. Every number has a sign, and the sign is in front of the number. So the first one, -4 plus -2. Same sign or different? Same. They are both negative. So I add their absolute values. What is 4 plus 2?
6.
And I keep the common sign. -6. Okay? Let's look at the next one. Because of the example, it is the same sign again. Same sign, add 5 plus 10.
15.
And keep -15. All right? Questions? Same sign, add and keep. That's the first part of our little catchy little saying there. Example 2. Different sign. What do we say? Different sign, subtract. And we take the sign of the larger number, then we'll be exact. So, different signs here. Do you see that 5 is what? Positive or negative?
Positive.
10 is negative. So they are different signs. So my rule says to subtract their absolute values. What is 10 minus 5? 5. And we take the sign of the larger number. 10 is negative. Then you'll be exact. And that makes sense, right? If you have $5 and you spend $10, you're in the hole, $5, right? But we can think of money, all right? Money is a really practical example of integers. All right, -5. What about 8 plus -4? Different sign. Miles, what do you think?
4.
He says 4. Do you agree? 4 or -4?
4.
Why positive?
Because
8's bigger. 8's bigger. All right. Do the right-hand column. Do those two problems. Compare your answers in your groups, and we'll go over them. Okay. -3 plus 7. Everyone. What is it? Okay. Is it 4 or -4?
4.
Why? 7's bigger. -15 plus 8. Why? 15. Very good. And that makes sense, right? We owe someone $15 and we pay them back $8. Do they say, "Oh yeah, you're fine now. You don't owe me any more money"? No, they're like, "Pay up, $7 more." Okay. All right. Okay, very good. -7. So that's example 2. Now, in example 3, we need to talk about eliminating these, what we call double signs. Okay, you don't have to write down the first bullet point, but you need to read it with me. When you're solving equations, so this is more for chapter 2, you will not see these parentheses. So you need to understand the following rules. Adding a negative is the same thing as subtracting it. Again, you don't have to write that down, but I do want you to write this down right here. 10 plus negative 4. Here's what I call a double sign. When you see the plus a negative with no number in between, that's what we call a double sign. You're not going to see that when we're solving equations. You need to understand that that's the same thing as 10 minus 4. Plus a negative is the same thing as subtracting it. And I'm going to push you in that direction. I don't want you to make a habit out of writing it this way. Okay? I want you to recognize, and when I say this way, it's plus the negative with the double sign. I want you to recognize that 10 minus 4 is the same thing. Okay? They're both going to be 6. All right, same thing over here on the second one. 15 plus negative 5 is the same thing as writing it 15 minus 5. All right? Okay, so you just need to understand that. All right, what do you see here in the second one? A double negative sign changes to a positive. This is very important because it changes your answer, as opposed to the first one where your answer is going to be the same either way. Okay, 5 plus 6 is 11. We've got to change the double negative to a positive. Okay, so double negative sign equals a positive. All right, that part's important too. All right, so when I say adding a negative is the same thing as subtracting it. Okay, so we need to understand that part. All right, double signs. Any questions? Okay, we're going to take about three minutes or so, 3 to 4 minutes, and work these 5 problems with your partners. Okay, and we're just specifically answering each question, 1 through 5. All right, make sure that you have some type of reasoning for number 3. Okay, negative 8 plus 20. What is it? Tell me. 12. Different sign, subtract. 30 plus negative 30. 0. Can anybody tell me what property that is? What is the property that's an example of? Kennedy?
Additive inverse.
Yes, ma'am. The additive inverse property. Take a number and it's additive inverse. That's a fancy word for opposite. Don't be scared by that word. Oh, that sounds really confusing. Additive inverse is its opposite. Take a number and its opposite, and the answer is 0. All right, so that's just kind of the name, putting a name to the rule, okay, or to the expression. All right, so 3 plus negative 4 is the same thing as negative 4 plus 3. Agreed or no?
No. Yes. No.
Okay, so let me ask you this. Is 3 positive in both expressions?
Yes.
Is 4 negative in both expressions?
Yes.
So it is the same thing. And the property here, okay, so I thought this was going to be a review. I'm gathering maybe it's not. Okay, so here's the name of that property. Commutative property. Yes, this is the commutative. Okay, I'm going to spell out the whole word. Commutative property. Okay? Commutative property says I can change the order without changing my answer. Okay? So 3 plus negative 4 is what? Negative 1. Negative 4 plus 3 is negative 1. Do you see how I changed the order? This can really work to my benefit. Okay, and we're going to see how in just a minute. That we can switch numbers around in a set of numbers so we can match up our opposites together, because what happens with opposites? They cancel. Those additive inverse property. We'll see that in just a minute, okay? Number 4. Is number 4 true or false? True or false, guys?
True.
It is true. Add and keep. Same sign, add and keep. Okay, so if they're both negative, I add them together, and yes, they will always be negative. Number 5, true or false? Give me an example of when this statement would be false. Can anybody give me an example of when you take an integer and you add its absolute value and it's not going to be 0? Can anybody give me an example?
Wait, I don't have an example. I had a question, but
Okay, hold your question for a sec.
When they have 5, like in the absolute bars, and then 0, like the absolute value is still 5, so if you add it, it'll be 2.
Yes, okay. Take a positive integer. A positive integer, 5, and add its absolute value, which is 5, and it doubles the value. Now, if you take a negative integer and add the absolute value, yes, it's 0. But if it's a positive integer, it's going to double it. Okay, so it's sometimes true, but it's not always true. All right, so that's it for the classwork. Okay, all right, moving on to the last example. All right, modeling real life. Like I said earlier in the lesson, the clearest connection between integers and real life is money, okay? You make money and you spend money. Would you agree? We all spent money today, or some of us in the lunchroom. Anybody spend money today in the lunchroom? That's a negative value for money. Can anybody think of some positive values for money? When would money be a positive value?
you work and get paid.
You work and get paid. Is that what you're going to say?
You win the lottery.
You win the lottery, yeah. Okay, anybody else? Avery? Okay, someone gives you money as a gift. If they loan you money, is that still positive?
No.
If they loan you money?
Yes, 'cause they're
It
giving
is because you have the money, but you owe them money, which is still negative. Okay, something to think about. All right, so yes, those are all practical examples. So here's what it says. The list over here in the table shows 4 account transactions. Find the change in the account balance. All right, so we want to see when we combine everything together, what is the change in the account balance? Do I have more money than where I started, or do I have less money? All right, so what we're going to do is we're going to combine all of these values. Negative 40 plus 50 plus 75 minus 50. All right, go ahead and let's write this out. Plus 50. Shh. You're getting ahead of me. Okay, and when you write that out, something might catch your attention. Okay, has everybody written that expression? This is us showing our work, so if you have one similar to this on your homework, this is kind of how you would show this. Anybody notice anything? Raise your hand. Anybody notice anything? Kyle, what do you notice?
The commutative property.
And if you used commutative, how would you rewrite it?
7. Positive 50 plus negative 50 equals 0.
Minus 40 equals 75. Why did I pair my 50s together? Kennedy?
So you could cancel them.
So you can cancel them out. Why would I go through, okay, I got to add and subtract and apply my rules? I look at the overview and I look for the opposites. And then I can use the commutative property to pair them together. Commutative property says I can rearrange my expression without changing the answer. Okay, we just keep the sign. Now, I think you said plus negative 50. That would be fine too. Just make sure you put it in parentheses. Okay, my 50s cancel. And now what's negative 40 plus 75? Just tell me, what is it going to be?
35.
Okay, so what if my beginning balance was $50? How much money do I have now? $85. Okay, so it's added to whatever my balance was before. And the goal is, right, to make more money than you spend. What do we call that? When you make more money than you spend. Anybody know what we call that? Living within our budget or means. Living within our means. And if only all of America practiced that, maybe we wouldn't be in so much debt as a country, right? Okay, so that's just economics, and we need to make more money than we spend and stay in the positive, okay? So that's kind of just a real life example of what we're talking about with integers. And that's everything for our lesson today for section 1.2.